Hello and welcome back to the second part of part 1. In this agenda, we will lay out the agenda for the remainder of the presentation. What we're going to talk about over the next 6 or 7 hours, depending on how long this takes, that's about the estimate, about 7 hours, is the evolution of BI models. We'll talk about what did we want to build, how did we get into this, what did we want to build, because it's important to position what we wanted to do such that you understand how did we come to be in this place and how did we get to have what it is that we have and why is it good. We'll then we'll talk a little bit about competition, but then we'll get into BI4ALL and how to read the data model. And that's about the time that our business sponsors and our business analysts might like to take their leave. We start to get, in bullet 3, we start to get into the technology details. We will go through BI4ALL in detail, such that you can really come to understand exactly how BI4ALL works and exactly how wide the coverage is for BI4ALL, the base model. We will then talk about each of our industry verticals in order of depth and how good we think they are. We think our telco data models are second to none. We argue that we're the kings of telco, and we argue that our friends at Teradata have a great offering, and our offering is significantly differentiated from our friends at Teradata. But we know that we are way better than anybody else other than Teradata in the telco space. So we lead with our strong suit, telco. Retail, we are also great in retail. Our experience over the last 7 or 8 years with our friends and colleagues, Keyword Consulting in Germany, plus other experience that we've had in other large major retailers in Europe and around the world, and the research that we've done in retail, we think we're pretty strong. And again, our friends at Teradata are very strong in retail, and I would actually say, by all means, go and talk to our friends at Teradata. And if you want a connection, one of my very good friends is a business development manager in Teradata up in Boston. His name is Tom Casey. By all means, you can contact him, or I'll even give you his link. I think that as long as we compete fairly and honestly and show our prospective clients what it is we think we're good at, that I absolutely encourage you to go talk with our friends at Teradata and then come back and compare what we've done. Hey, if you think there's some things we should add, by all means tell us. Going down the list, media and web, we do media and web, but we would be the first to say that our strength in those areas is not as strong as telco and retail, and really nobody has great media and web data warehouse data models out there. And it's kind of surprising to me that it's gotten so late in the game without more competitors coming into the media/web space. After that, we'll talk about the issues of implementing these sorts of models and then the process of implementing these sorts of models so that you, the voter, understand, okay, now we've got this data model and I understand the model that you've talked about, but how do you go about implementing this? Can you please explain that so that I can understand that and understand why is it different? You say that implementing BI4ALL is vastly different to implementing anything else. I would have thought implementing a data model is implementing a data model. So you're going to have to explain to me why this is different. And at that level, we get a lot of interest from people who've implemented data warehouses before, because we claim that the way that we do it is vastly superior and compresses the timelines vastly reduces risk, etc. So it's not just the data model that makes a difference, it's the way in which we implement the data model as well. And our implementation mechanisms rely on us using our own tools, CTL, and rely on us using our own methodology. So we have our own customized methodology for how we implement these sorts of projects that our business partners are trained and certified on. And so this is another reason why we don't want to just hand over the data models to people and say, off you go, because You don't know our methodology, you don't know our tools, you don't know how to go about this project. So the likelihood of crashing and burning is significantly higher, just to save a bit of money. So we suggest you invest the money with the people who are of the highest caliber and the highest skills, and that pays back to you over the next 10 or more years. If you don't do that and you implement these models in a optimal manner, you'll pay for that as well for the next 10 or 15 years. As one of the greatest one of the greatest system architects I ever met, a man by the name of Brian Kent, said to me, 5 years after a system is implemented, nobody remembers the date it was implemented on, but everybody knows its shortcomings and weaknesses. And that's true. 5 years after you implement any system, nobody could give a damn about what date it went in. Before it's implemented, everybody's arguing about the date, and the implementation date is treated as so important because it's one of the few things that can be measured. 5 years down the track, nobody knows when it went in live, but all the deficiencies, all the problems, all the issues with it, everybody knows about those. So what Brian was getting at when he was talking about these things was, forget about the implementation date, it's not important. Think about the life of the system, which back in those days we used to estimate at 7 years. And it's pretty funny because the system that he designed, that I implemented in many places, lasted for 25 years. I've never heard of a system lasting for 25 years in any situation. So that tells you about how robust and long-running that system was. I was told recently by an old friend of mine at IBM that they'd finally decommissioned the last instance of what we were implementing back then. But 25 years, that's a long time for any computer system to be in production. And it was in production in many countries. So we're going to go through the process of BI4ALL modeling, and we're going to make sure you understand why we think you should do it properly, even if it seems like you're doing a little bit more work during the development process than what you might otherwise want to do. And of course there'll be a summary and a next step slide as well, as there is in all our presentations. Now this technical presentation is not a sales presentation. We're not here to sell you, the voters, on BI4ALL, okay? If anybody wants a sales presentation, please check our videos on our website or give us a call and we'll give you a sales presentation, right? This is very much an evaluation workshop. We do have just one sales slide that we would like to include, and that is the difference between going with packaged data models, without packaged data models on the left, and with packaged data models on the right. Do you buy or build? On the left, you have to go through the normal things, the requirements definition, business understanding, schema design, query optimization, planning, ETL definition, reports, etc. You have to go through all those things if you build your own data models. What we do is we come into an organization, yeah, we do a little bit of business requirements, but we basically take what we have and refine it and implement it. Okay? Refine it, implement it. Find out about all your data, do all your data profiling, understand the information you have, understand your business, catalog all that, and implement it. Refine, implement our data models. That's what we do. And the timelines are vastly different. Okay? We have our best reference, our best public reference, which we like to talk about. We did with Sean Kelly and Associates, and this was Carphone Warehouse, the TalkTalk division, a 4 million subscriber broadband provider in the UK. And the data warehouse architect from Carphone Warehouse has gone public, said at conferences and places like that. So, you know, I'm quoting him as a public quote, said that the 8-month project that we did there achieved, would have taken 2 years at the normal rate of progress. He thought that we were about 2 years in 8 months, which is a very good reference given the skill of that man, Brian Ganley, and he's given us a personal reference on our website as well, so you can go and have a look at that. Brian is, I have great respect for Brian. He's just one of the smartest people I've come across, and his skills and knowledge and understanding in data warehousing and business intelligence his top shelf in the UK. So for Brian to say something like that about us is really, we very much appreciate that. So what components do we, IBI, offer through ourselves and our business partners? We can do the business consulting, we can do marketing strategy for you, we sell our own suite of ETL tools and all the tools necessary to build a data warehouse. We deliver the BI4ALL models in the industry verticals, and we have a suite of analytical applications on top, and our business partners have built their own applications on top. Our analytical applications are now stabilized. We don't promote them so much, but we do use them as examples, and there will be in this presentation an opportunity to click on and go look at those examples. In this workshop, we are only going to talk about the BI data models. We're not going to talk about everything else, okay? This workshop is about ticking the box, do we want to buy BI4ALL or do we not? And that's all we're going to talk about for the most part. So, to understand why BI4ALL is a good idea, you need to understand the evolution of data models and where did BI4ALL come from. If you don't understand the evolution of data models and where BI4ALL came from, then you can't possibly understand the value in BI4ALL and you'll vote no. If you understand the evolution of models and where BI4ALL came from and what are the problems that they solve, then you are much more likely to vote yes. So we need to present this information to you. Back in the early days, everyone used third normal form or a derivative of it. There was Bill Inman, who came out with the first way of really designing data warehouse data models, and that was third normal form plus time variance and stability analysis. And we have a video of that on our website if you want to go and look at it. But that's what was being used early on, and NCR are still using third normal form predominantly. So if you go and look at the Teradata, sorry, I should say Teradata, they've changed the name back now. So Teradata, if you look at Teradata and you look at the telecom operators model, which Teradata operates or offers, and which many of our consulting clients use, you will see that it's a third normal form data model. It's very sophisticated, very complicated, very comprehensive, and many large companies use it, and feel free to go and ask them about what their opinion of it is. I think it's a little bit ingenuine of me to offer my opinion, but because I'm obviously biased, right? I will stand up and say I'm obviously biased talking about Teradata data models because they are our #1 competitor and they are a fine competitor too and have been for the last 20 years. Now many people moved to dimensional models in the 90s with the advent of Ralph Kimball's book in, I think it was either 95 or 96. I can't remember exactly which year Ralph brought out his first book. But when Ralph brought out his first book, I was the star schema evangelist in Australia. So I was already trained on how to build star schemas in 1994. I tried my first one in 1993. It was only marginally successful. And I was trained in late 93 and 94 on how to build star schema databases. Indeed, I had to bring a guy out from Metaphor to help me design the first star schema databases and learn from him, and he became my mentor in 94, 95. So dimensional models became popular through the mid-90s, and through the mid-90s I was handing out copies of Ralph's book a bit like candy, and I was encouraging all the major companies in Australia to look into dimensional data modeling. Now, some form of dimensional models is now normal. Even in front of Teradata data models, you'll often see cubes, Essbase, those sorts of things, Cognos. So cubes are always dimensional. So some sort of dimensional model in the business intelligence ecosystem is fairly normal now. And just for those of you who don't know, it wasn't always that way. I was running around in the days of talking about dimensional models, being thrown out of companies with dimensional data modeling. You're completely insane. Nobody builds data models like that. Get out of our company. I was thrown out of companies for talking about dimensional data models from 92, 93 through to about 95. It was only when Ralph released his book, and I had a book to wave at them and say, look, it's not just me who thinks dimensional data models are a good idea. Here's a whole book about it. So then people started saying, oh, well, we better read the book. And so it wasn't always the way that there were dimensional models around. Now, this mishmash of Bill's idea and Ralph's idea came together in 1995 with the guy who was my mentor, the guy who trained me, because he went off to go into another life insurance company. Once he worked on the life insurance company that I brought him over to work on, he had life insurance ticked on his resume, and so he went off to do another life insurance company, and it was a very complicated organization he was doing. So he wrote to me and said, you know, a dimensional model won't satisfy what it is the client wants, because they needed this archive. And until those days, you either built an archive or you built a dimensional model. And so in conversation, we decided to try a mixture of both. And my friend worked for PricewaterhouseCoopers at the time. And so we tried a mixture of both, and that worked out pretty well. And this is what it was. We discussed this in 1995, and then my friend, who wants to remain nameless in this presentation, implemented what we discussed, and then we kind of looked at it, and it was pretty cool, and we thought it was really good. Now then, we didn't have any such thing as an ODS in 1996. Bill really only gave this thing a name. I'm not sure when his first book came out on ODSs, but the ODS name I think was about 98. But we had something here, and we were having troubles with clients, and we were cutting pieces out and building these transaction things. Because what happened in some of our early clients was we built the data warehouse, and then this was the only place that all customer data was integrated. So the operational systems guys went, hey, this is great. We can get everything we want from one database. And what was happening at that time in the 90s was call centers were on the rise. Everybody was starting to implement call centers. And so we were working for large insurance companies who were expanding their call center, and our data warehouses had the only consolidated lot of information. So they would put these call centers on the front of our data warehouses, and of course then that was processing OLTP transactions, and querying it as a warehouse would kill the OLTP transactions. Then we had to cut a piece out of the warehouse and retrofit it to put it onto the call center. So by the time we got to 1996, we already understood we needed to have a database which was the transaction database that the customer could talk to, or the call center and that could talk to, and we needed another one for the data warehouse. I can't remember if it was 96 or 97 that Bill coined the name Operational Data Store. I do know I sold a deal in 1997 where we were talking about operational data stores. We called it the OpKIF at the time, the Operational Customer Information File. We didn't even know to call it an ODS. We were calling it, I think in 97, we were calling it the Operational Customer Information File. And we would say to our prospective clients, you know, are you doing call centers? Do you want an Operational Customer Information File? So that morphed into the name ODS. Well, Bill named it ODS, and then we adopted that. So this was best practice, and I'll just walk through it for you because this was fantastic. When we came up with this idea and we used it, we thought it was fantastic, and I implemented a lot of these. And this became quite standard. Almost everybody adopted this. IBM adopted this, PricewaterhouseCoopers adopted this, Teradata, NCR to an extent adopted this, although their dimensional stuff was typically in cubes. Back those days, Holos cubes and things like that, and S-based cubes. So just to explain this, you'd have the normal various operational systems of records. You would have the integration transformation process with metadata everywhere. Trying to get good metadata was always an issue back then. This integration transformation would flow into the operational customer information file and then flow into the data warehouse. Now, if you wanted to cheat, you could go round We typically don't mark that, but you could go round directly from here into the archival data warehouse if you didn't want to push some piece of particular data through the operational data store. We'll call it operational data store because that's how it's been named now. Now in the data warehouse, given the disk that we had at the time, a couple of years worth of data in there was about as much as you could afford, given the price of disk. And this was a third normal form time variant model. This was an archive, and we'd throw stuff onto tape. And not many people today, you ask somebody under the age of 30 today if they've ever used a tape, and they've probably never used a tape, right? But of course in 1996, we were still using tapes to back things up, archive stuff. From that, and that was planned to be for a long time onto the tape. Now from the archive, we would take stuff and we'd put it into star schemas, yeah? And we had a way of keeping the detailed transactions in here as in the base, so we would lightly summarize the star schemas into here. And we would keep structures in here going up into here as well. So this was archival, which was Bill Inman's style of data modeling. And then this was dimensional, which was our new way of data modeling. And this was third normal form because it was transactional. So there were 3 different modeling techniques in there. And then we would take this information and highly summarize it up into star schemas or cube type products. Because we did a lot of work in these days with Holos, which was a great product, which went the way of other products. It died off for whatever reason. So archiving, third normal form in here, archiving here, lightly summarized, highly summarized. Now, as I said, this was great. I implemented lots of these. Okay. So what is good about this data model? It's comprehensive. Number one feature is comprehensive. The breadth of data is a complete archive plus analytical layers, and you can build whatever dimensional models you want. And because the archive is historical, you can actually go back and build instances of dimensions as they were at a point in time and hot swap them onto onto fact tables and things like that. With these data models, there was nothing wanting, okay? Which is why they were adopted. This was adopted by IBM in I think 97 or 98. I'm not sure who moved from PricewaterhouseCoopers to IBM and talked to Barry Devlin. Barry Devlin was the guy who did this. I don't know who talked to Barry Devlin, but Barry Devlin moved towards this way of doing things in the 97-98 time frame. I became aware of Barry in 95 when I was doing the banking data warehouse for IBM for the RB2020 banking system. So it was comprehensive. And of course the guy who thought of it was my mentor who was at PricewaterhouseCoopers. And so PricewaterhouseCoopers had become the de facto and had the most comprehensive way of implementing data warehouses. It was easy to use. Dimensional models are much easier to query and use than third normal form archival models. And of course for PricewaterhouseCoopers, it makes lots of money for the vendors and the consultants. Building these things back in the day was quite time consuming and expensive. So the consultants made out like bandits. And fair enough, because they were bringing tremendous business value to the business. So the model was adopted by the large consulting firms, for example PwC, which is now part of IBM, and IBM, and to a lesser extent Teradata. What is bad about that way of doing things? Because everything's a compromise, everything's a trade-off. The thickness of the lines represents the complexity of the ETL. So we'll just go back to that. The thickness of these lines represented the difficulty and complexity of the ETL. So getting data through the integration transformation process, getting it through the ODS and into the archive was fairly complex, tricky code, depending on how you did it. And then getting it from the archive up to the summarized star schemas was another transformation, given that these are 3 different data modeling styles. This was another transformation. So the consultant companies made out like bandits for all the code that needed to be developed. That was fine. Oh, sorry. There was a great deal of redundant data that we did develop tricks to get around, but there was still a great deal of redundant data. The 3 different modeling techniques mean that these models will never coexist in one set of data. Separating is designed into the solution. So we'll just mention that again. 3NF, third normal form plus time variant model, and often stability analysis as well, which you can read in our other papers, and dimensional. So these 3 different data modeling styles cannot possibly cohabit in a single data set. Therefore, data redundancy is automatic. Okay? Can't be helped. And so when we were looking into this, we were saying, well, this is a great solution. This is better than anything else we've ever seen. Great coverage, great archive, can rebuild dimensional models, fantastic toolkit for building an enterprise data warehouse. But damn, it's pretty expensive to do this. And selling these things was pretty hard because of the expense and the return on investment equation. So they were expensive to build when you built them that way. So a number of our customers, when we presented this and the associated price tag, said, well, how can we make it cheaper? And of course, the way you make it cheaper is going without some of the archive. That's how you made these things cheaper, and going more with just a dimensional model. So we also built in the day data warehouses that went straight from the staging area through to a dimensional model and kept everything in staging. So not as good, but cheaper. And like I said, everything's a compromise. So how to avoid the bad? This was our question when we were implementing these things in the 97, 98 period. We're like, how do we make this cheaper? How do we get rid of this archive, this third normal form in the ODS, and this archive is just soaking up money like it's going out of fashion. And we tried really hard to solve that problem, and I can say that I failed, and the people that I talked about it with failed as well. There was one man who was incredibly bright, who at this point in time figured it out. And he worked for Sean Kelly and Associates, and that idea went into Sybase, which is where I saw it. So BI4ALL now makes it possible to get rid of the archive layer, and you will learn about that today. That is the most intellectual property protected piece of our presentation. You'll learn about how to get rid of the archive layer today. So the BI4ALL proposition is, you still have the same problem of getting your data through the integration transformation process, although CTL solves much of that problem. It is still fairly heavy processing to get it into the ODS as a star schema, and that's solved by our CTL tool. But after that, it's easy to get it into the archive. And there's no data manipulation going up to these things, because we build into the archive virtual cubes or real cubes, levels of summaries and things like that. And so this is all star schema. The older detail is all star schema. We're now retaining stuff for easily 3 to 5 years. We're not using tape so much as optical or something else like that. Indeed, these large Netezza boxes, we're still just throwing it onto high density disk. So the new BI4ALL proposition is that you only have very light processing through to the warehouse and little to no processing into the summaries. And this makes a huge difference. This makes a huge difference to the cost of the overall project. We, compared to the 2 design methods, we are easily 50% faster using the different design methods. Okay, easily 50% faster than what we used to be for, and it's to be emphasized, no loss of functionality. So way back in 2002, when we were thinking about all these things and we were implementing these sorts of models, there was a problem that we saw in the marketplace. And this was really from 2000 to 2002. It was the analytical application hype. And those of us who were around in those days still remember the hype of these analytical applications. And the issue was they were simply too expensive to customize and implement. People were selling, the one company remained nameless, selling a packaged app for 150,000 US dollars. That was taking 300,000 or 400,000 US dollars to customize. And so why would you spend 150,000 to buy something that costs twice as much to customize? And they failed. The analytical applications space failed. Cognos, as one example, released a package that had 2,600 reports in it. And when somebody would ask, well, do you have a report on such and such in it? Their answer was, it must be in there, we've got everything, right? So this was not really a way of going about the analytical applications problem, but opportunity knocked. And the obvious thing was, if you could solve the issues of implementing the analytical applications, then you could make some money implementing customizable analytical applications. But there were hurdles. The number one hurdle was ETL, because the issue that people were having as they were trying to implement these analytical applications was the data model was designed, the applications were designed, absent knowing what the operational system would look like. So they had to take the data from the operational system and shoehorn it into the applications and customize the applications where the applications didn't meet requirements. The building of the ETL subsystem killed the value of buying the application. It was just as cheap to design the data model and the applications from scratch, then build it and go forward, as opposed to, okay, we've got the data models, we need to customize the data models and build the map these data models to this set of data source systems. So didn't work. CTL addresses that problem, and that's why we started with the ETL problem, because if we couldn't solve the disconnectedness of the ETL problem, we couldn't solve any other problems. So we solved the ETL problem first. Number two was the data models, which is now addressed by the BI4ALL models in terms of flexibility and customizability. And number three was the apps themselves, which we addressed through BI4ALL apps, which didn't be, it's not that our apps didn't become popular, it's that report services didn't become as widely popular as what we thought. So we discontinued working on those apps back in about 2008. We thought that in 2005, when Microsoft announced report services, that it would be huge. And it really hasn't turned out to be like that. So we solved the problems, and we're now able to successfully implement analytical applications at a much lower price point than everybody else. Okay. Now I just want to talk about problems in other models. Okay. So, and I'll just say other models, but what I mean by that is our friends at mostly Teradata and IBM, but Oracle and SAP to a lesser extent. All models have areas that we could do better. Nobody can build a large, sophisticated data model and get to the end of it and say there's nothing they'd change, given the benefit of experience and hindsight. Models take time and effort to understand, and sophistication has its price. Time and effort to customize. The number of null fields is relevant on Oracle. I don't know about Exadata, but number of null fields on standard Oracle databases is relevant. It's irrelevant in databases like IQ or Netezza and things like that. Netezza has moved to have partially bitmapped data models. The big problem in other data models is the time and effort to write the ETL subsystem. That's where your money goes, right? Your money goes in writing the ETL subsystems and customizing the data models. So the BI4ALL models were designed to solve all these problems. In particular, although it might sound strange, BI4ALL, once you come to the new paradigm of thinking, is trivial to understand. The issue with BI4ALL is everyone is in the prior paradigm of thinking. And in the prior paradigm of thinking, you can't understand the BI4ALL models. They seem very strange. So you have to make this step, and it's a leap of faith to get across this step to a new paradigm of thinking. And once you get to the new paradigm of thinking, it's like the light bulb goes off and you go, aha, now I understand it. Okay? And I will liken it to riding a push bike. When we were kids, most of us couldn't ride a push bike at one point in time. And riding a push bike was this mysterious exercise that our older brothers or sisters seemed to accomplish with ease, but we kept falling off our push bikes when we tried to learn how to ride our push bikes because we didn't have this thing called balance. Okay, we couldn't adjust to balance the push bike. But learning this thing called balance is not like a progressive thing like learning mathematics or learning chemistry or learning physics, where each piece builds on the prior piece, builds on the prior piece, builds on the prior piece. Balance is one of these things where either you got it or you don't got it, right? Either you can ride the push bike and stay upright or you can't. And it's not a progressive learning thing. And as we're learning to ride the push bikes, you know, most of us had some skinned knees and skinned elbows as we fell down. And that's as it should be. It is the same with BI4ALL. As you go through this process, you'll be confused and you won't get it and you won't understand it. And then at a certain point in time, the light will go off and you go, aha, that's so easy. Why couldn't I see this before? Which is like learning to ride a bike. Once you can ride the bike and you can balance, you go, how was it I wasn't able to balance before? I don't understand. Now it seems so easy to balance a push bike. Why couldn't I balance it before? It's exactly the same experience. And it's important to remember that. We dramatically reduced the customization time of the data models, and that's also now through our tools. We are about 5 times faster than what we would be with other entity relationship modeling tools, and we are experts in those tools, so we do know that. And we vastly reduce the number of null fields, so if your database actually requires processing or disk for null fields, we dramatically reduce the number of null fields in any particular data warehouse. Problems with other data models is the architectural complexity. A lot of these other data models are designed to contain every field known to man, which means you have to use their naming standards. And if you don't use their naming standards, you can't implement it because the applications are built on their naming standards. So your company must adopt the naming standards in the new data model, okay? Which is a big ask if you're a telephone company. Whereas we are happy to adopt your naming standards. The complexity and cost in developing and maintaining ETL, a great deal of redundant data, although we developed tricks to get around that, others haven't. And the 3 different modeling techniques mean that models will never coexist in one set of data. So what did we want to build? Okay, given this was the situation in 2002, what did we want to build and how did we want to make that? Well, we decided that we're going to bring to market the world's best packaged analytical applications. That's what we wanted to do. Some really cool, really good packaged apps built on top of a sophisticated data model. And we wanted it to look something like the following. Now, at this point in our workshop, we usually cut to a short demonstration of the applications. And you can find a longer demonstration. Normally it's about 10 minutes that we do as a presentation of our applications. Now, because this is a video and it's disconnected in terms of time, you can find this presentation on our video page. It's on the videos technical BI4ALL tab. It's called BI4ALL Demonstration for Reports. And you can go to that video and you can watch a 1-hour video of what did these reports look like. Now, you are presumed to have watched this video at this point in time. After here, we will presume that you've seen that video and run through it. If you didn't, just a refresher is we had campaign analysis reports, which look like this with the red, yellow, green highlighting. You can note the plan versus actual and the color coding. You can note the drill down and things like that. But you should have seen all this in the report. As I said, these have now been stabilized. We're not saying that we're selling these to you. We're saying you can use these as an example. We had sales analysis reports, which you could look at. Say white goods, home improvement, entertainment, unit revenue variance by product category, plan versus actual, unit variance by product category. And then we had the drill down for the plan and unit amounts and things like that. And we even did things like mapping back in those days. This was 2006, 2007. We were able to build maps in report services using the Dundas software charting controls for report services. But Dundas eventually sold all that off to Microsoft, and there was a disruptive evolution of the technology. And when that disruptive evolution of the technology happened, we said, well, Microsoft hasn't made this really very successful, so let's not do this anymore. It's basically what we said. Now, this concludes part 1 of this presentation. We'll continue on with part 2 shortly, or whenever you like, given that this is a video. So thank you very much for listening to part 1 of this presentation.